Chapter 9: Motion and Time. Introduction. Movement is referred to as motion. Another way to describe it is as an ongoing shift in an object's position or location over time. You were taught about several motion kinds in your prior class. You are aware that motion can occur in three different ways: linear, circular, or periodic. Which of these three motion kinds can you name? Additionally, we encounter a variety of motions throughout our daily lives. You have undoubtedly seen different cars on the road, as well as the movement of fans and pendulums in wall clocks. Several other living organisms exhibit motion as well, such as fish in water, ants on the ground, snakes, etc. Have you ever noticed plants moving? Not at all, but why not? In actuality, plant motion is so slow that the eye cannot notice it in a brief amount of time. Motion. We have learned that a body is said to be in motion when its position changes with respect to another body which is fixed at its position. For example, if you move in a room, your position changes with respect to the door, which is fixed. The object which can change its position is called mobile, and the object which cannot change its position is called stationary or an object at rest. We can say that motion is always detected with a stationary object as a reference. Hence, motion and rest are relative. If you are moving in a car, you are in motion relative to a signboard on the road, but you are at rest relative to the person sitting next to you. Therefore, an object is said to be in motion when its position changes with time, relative to another object which is at rest. Looking at the bigger picture, we all are constantly moving as the earth rotates and revolves around the sun. Then why don't we feel the motion of earth? Discuss this question in class and note down the responses you get. You also learned about types of motions in the last class. Let us quickly recall them. Slow and fast motion. Which one moves faster, an aeroplane or a train? A car or a bicycle? How do you know? To decide this, we also need another parameter, time. The slow and fast motions are detected with the help of time. Measurement of time. Time is measured by a watch or a clock these days. Do you know how man started measuring time? Initially, the time was measured as day and night. Gradually, people developed simple devices such as a sundial or an hourglass. Jantar Mantar in Delhi is an example of one such sundial. People estimated time by the angle of sunlight and the length of shadow at different times of day. These days time is measured by clocks with a dial showing 1 to 12 hours or digital clock. Unit of time. There are different units in which time is measured. The SI units of time is second. It is denoted by S. There are other units of time too. 60 seconds, S, is equal to 1 minute. 60 minutes is equal to 1 hour. 24 hours is equal to 1 day. 30 days is equal to 1 month. 12 months or 365 days is equal to 1 year. 100 years is equal to 1 century. Speed. Now that we know about time, let us see how it detects whether a motion is fast or slow. Motions of different objects are compared by measuring their speeds. Speed of a moving object is defined as the distance traveled by the object in a unit time. The unit time can be in seconds, minutes or hours, and the distance measured can be in meters or kilometers. In terms of a mathematical formula, speed is equal to distance covered upon time taken, or V is equal to S upon T, where V is equal to speed, S is equal to distance, T is equal to time. Speed can be expressed in different units. Speed is equal to distance upon time is equal to m upon s is equal to ms raised to the power minus 1, or kilometer upon hr is equal to kmhr raised to the power minus 1. The unit ms raised to the power minus 1 or meter per second expresses the distance traveled by a body in meters in 1 second. Similarly, kilometer are raised to the power minus 1 or kilometer per hour expresses speed as number of kilometers traveled by an object in 1 hour time. Let us learn how to calculate speed. Example 1. Raj walked to school, which is 2 kilometers from his house, and reached there in half an hour. Calculate his speed. Solution. Distance traveled by Raj is equal to 2 kilometers. Time taken is equal to 0.5 hours. Raj's speed is equal to 2 kilometers upon 0.5 hours is equal to 4 kilometers per hour. Example 2. A moving train covers 20 meters in 4 seconds. What is its speed? Solution. Distance covered by train is equal to 20 meters. Time taken is equal to 4s. Therefore, speed is equal to 20 upon 4 is equal to 5 meters per second. Example 3. A car travels a 30 kilometers distance in 15 minutes. Calculate its speed. Solution. Distance traveled by car is equal to 30 kilometers is equal to 30 multiply 1000 meters. Time taken is equal to 15 minutes is equal to 15 multiply 60 seconds. Therefore, speed is equal to distance upon time is equal to 30 multiply 1000 upon 15 multiply 60. ms raised to the power minus 1 is equal to 33.33 meters per second. Example 4. Rakhi's school bus took 20 minutes to reach school after she boarded it. If the bus moved continuously with a speed of 25 km per hour, calculate the distance between Rakhi's school and home. Solution. Time taken by the bus is equal to 30 minutes is equal to 30 upon 60 hr. Speed of the bus is equal to 25 km per hour. Speed is equal to distance upon time. Distance is equal to speed multiply time is equal to 25 multiply 30 upon 60 is equal to 25 upon 2 is equal to 12.5 kilometers. When a bus or car moves on road, its speed does not remain same all the time. On a smooth and empty road, it will move faster, but when there is traffic or a red light, it will slow down. Such type of motion is called non-uniform motion. When a body moves unequal distances in same intervals of time, it is said to have non-uniform motion. However, speed of certain objects like planets or falling water in a fountain always remains the same. The motion of these objects is called uniform motion. When a body moves equal distances in equal intervals of time, it is said to have uniform motion. Let us understand this with an example. Time. Car distance 0, 5, 0 m. 15. 1 m. 25. 2 m. 35. 3 m. 45. 4 m. 55. 5 m. Equal distance in equal interval of time. Time. Car distance 0, 5. 0 m. 15. 1 m. 25. 3 m. 35. 6 m. Unequal distance in equal intervals of time. Using graph to show motion. You must have seen a graph sheet. Graphs are commonly used to represent data. A 2D graph has two axes. The horizontal axis is called x-axis and the vertical axis is called y-axis. The point of interaction of axis is the origin. The origin is denoted as 0, 0. There are 4 quadrants in a graph. The points above 0 on y-axis and to the right of 0 on x-axis are positive. The points below 0 on y-axis and to the left of 0 on x-axis are negative. Since distance and time are positive, they are always plotted the above x-axis and to the right of y-axis. On a graph, scales have to be chosen to show large values of data. For example, in a distance-time graph, 1 centimeter can represent 1 meter or 10 meters or 1 kilometer, depending on the data. While plotting a graph, the independent variable such as time is taken on x-axis and the other variable is taken on y-axis. The different values are plotted at different points. These points are then joined to obtain the shape of the graph. A graph can be straight line or curve. Sometimes all points on a graph do not fall on one straight line or curve. In such case, a line of best fit is drawn in such a way that equal number of points are above and below the line. Let us see how some other distance-time graphs look like. An object at rest. When an object is at rest, its position does not change with time. Non-uniform motion. When an object is moving unequal distances in equal intervals of time. How to calculate speed from a distance-time graph? The speed of a body can be calculated from its distance-time graph easily. For a graph of uniform linear motion, speed is given by the slope or gradient of the graph. Consider the distance-time graph given in the figure. Speed is equal to slope is equal to y to minus y1 upon x to minus x1. Choose any 2 points on the line, A and B. Draw perpendiculars from these points on both the axes. Perpendiculars from point A meet at x1 and y1. Similarly, perpendiculars from B meet at x2 and y2. The slope can be calculated as slope is equal to y to minus y1 upon x to minus x1 is equal to speed. Example, let us calculate speed of a body from its distance minus time graph. Speed is equal to slope is equal to 40 minus 20 upon 8 minus 4 is equal to 20 upon 4 is equal to 5 meter per second. Types of graphs. The graphs we studied till now are all line graphs. There are other types of graphs used for different purposes. Pie charts and bar graphs are used to represent data. Simple pendulum. Let us learn some more about a simple pendulum. It contains a small mass, called bob, suspended from a fixed point through a long string or rod. The mass moves freely under gravity. The motion of a pendulum is called oscillatory motion. When the bob of the pendulum moves from one point, goes on the opposite side and then comes back to its original position, it is said to complete one oscillation. The time taken by the pendulum to complete one oscillation is called its time period. It is interesting to know that for small displacements the time period of a simple pendulum remains constant. The time period is independent of the mass of the bob. The time period of a pendulum depends upon the length of the string from which the bob is suspended. Longer the string, greater is the time period. Earlier clocks were based on the oscillation and constant time period of a simple pendulum. In a nutshell, motion is always relative to a stationary point. To measure the slow and fast motion, time is needed. SI unit of time is second. Speed is the distance traveled by a body in unit time. Unit of speed is ms. A uniform motion is when a body covers equal distances in equal intervals of time. A non-uniform motion is when a body moves unequal distances in equal intervals of time. Speed can be calculated from a distance-time graph by calculating its slope. The time period of a simple pendulum is the time taken to complete one oscillation. The time period of a simple pendulum does not depend upon the mass of the bob.